Welcome to Printable Science, and thanks for clicking. Due to their low price, these resin printers like this Anycubic Photon are becoming quite popular. But as people who have experience with the more traditional types of 3D printers, the FFM or FDM ones that use a coil of plastic which they melt and then it becomes cold, and that forms the object. These use a little tank of goop, which is kind of an epoxy type resin that is hardened by ultraviolet light. And that's basically how this works. The bottom of the tank is exposed to ultraviolet light that hardens a layer of the material. The carriage moves up. The next layer is exposed to ultraviolet light. It hardens and sticks to the previous layer, and so on until something's created. Now, the primary difference from a user's perspective with these particular machines is that there's two post-processing steps that you have to undertake, which some people find quite annoying. The first is that once the model has been printed, it needs to be cleaned off. The resin or goop that was not exposed still clings to the object, and it needs to be washed off in some way. And the recommended or most typical approach to that is to wash it in isopropyl alcohol. And some people use water, and some people use commercial cleaning products. The jury's still out on the best way. We invite you to check us out or keep tabs on what Printable Science is up to, because in a video soon to be released, we're going to be introducing a revolutionary different approach to post-processing of the cleaning of printed prints on a resin printer. The other problem is, or I should say the other post-processing step that you have to do with these types of printers is once it's been cleaned, once a part has been cleaned, it needs to be hardened or cured by exposing the entire object to ultraviolet light. And most manufacturers suggest you use sunlight. Why they suggest that is because, of course, sunlight is free, and it still keeps your conception of the cost of having one of these printers way low. That's very inconvenient, and many people who live in particularly or in parts of the country where at least in some seasons it's dark most of the time or a cloudy day, it doesn't allow you or provide you with the opportunity to get consistent results. So the approach that is often undertaken is to get a ultraviolet light source and then put that together so that you have more control and more convenience in terms of curing your prints so that they're finally ready for use. So today we are putting together a 3D printed curing chamber for your 3D resin printer. And it's a slightly more involved project than we've been pursuing recently on on these videos, but we hope what we've come up with will be a real help to those of you who are pursuing 3D printing with a resin printer. In addition to a few printed parts that are going to be required, you're also going to need to order these three things. One, a spool of ultraviolet LED lights, 5 meters. You're going to need a electrical connection clamp, electrical connection connector, and you're going to need an AC adapter to convert your line current into 12 volts. And you can check the info below, and you'll see that I've provided a link for where I bought these as a complete little kit. The only important thing to remember is that your AC adapter is going to have to kick out at least 5 amps at 12 volts in order for you to have things properly powered. The other thing that I want to point out is just the joys of designing for 3D printing. This plug, well, When I first received one and started the design, I figured it was a standard size, but no, it's not. They come in different lengths, and it can be quite confusing. And the thing that's, of course, most frustrating about that is that I'd already committed to a design, and it was only in getting ready to actually do this video where I happened to grab a plug that I'd ordered from another source that I thought was identical to this, that I discovered, no, they're quite different. Let me just show you what I mean. Here we go. The reason why this gets so frustrating is that these were all printed and they were no longer any good. And seeing as each one of these larger sections takes about 8 hours to print, it's pretty frustrating. But that's why you watch the channel, hopefully, is so that you're spared from having to use up this much plastic to discover that things don't work. So, as I discovered, what I thought were effectively a standardized connector are not, and here's two of them right here. As you can see, this one is longer than the other, and that required me to rework the design so that we could have a more flexible approach to securing these in place. Anyway, that being the case, that's what we did. So these are the 3D printed pieces that you'll need, and you can print those off from the files that you can download from Thingiverse or from our website. This is the large chamber itself, which has a channel on the inside for the LED strip to follow. And then we have the two pieces of the handle. And then we have we have our mount for the plug, and we'll show you how that works. We have a little spinner at the top, and the purpose of the spinner will be to allow us to regulate the amount of heat that's allowed to escape from the chamber. The ultraviolet light curing is more effective with a little bit of heat in it, but of course you don't want too much, so you'll be able to adjust the top to set the temperature to roughly where you want. That'll be top for the spinner on the other side of the chamber, and then we have some 3D printed screws for holding things all together. Now, in order to show you how this is put together, I've printed off the lower section, just a lower section of the chamber, so you'll be able to see more clearly exactly what needs to be done on the inside there. So just let me show you here. This is, as I say, just a small thing. Now you have a couple of options for, that you can proceed with. You can either print off and use the 3D printed bolts if you like, or you can use standard 1/4 inch thread bolts. Now, if you use the 3D printed bolts, you're good to go. However, if you use metal ones, for whatever reason, maybe you like the idea of greater strength, then you'll need a nut driver. Here's one that's available as a 3D printed file, and you can check our videos or Thingiverse to find that. And this is actually a 1/2 inch bolt, which are really only available on Amazon currently, but if you go into just about any hardware store in North America, you can easily get a hold of 1/2 inch and 3/4 inch bolts for this project. But if you do that, if you go for the 1/2 inch or the 3/4 inch, then you're going to need to print off some washers. There's files included for that as well, in order to take up the slack that's created by the greater depth of the printed screw. So this being a little small section of it, the first thing that we're going to do is attach the plug connector for the LED strip, and that will go in to the top, and the mount will go there, and then we should be okay. Then we take one of the ends of the handle and place it underneath, line up the holes, put in a screw, that always works better in theory, doesn't it? Here, I'll just pre-start these in here. So we've got these both started, and now we go back to where we were. We put the plug in, we put the mount beside it or on top of it to hold it in. We get the handle, and we can see the handle has two sides to it, if you will, one with a knockout in it and the other side flat. So we want the knockout facing in towards the chamber, not out. And we hold it over the hole, and then we just tighten up the screw into the handle. And there we go, like that. Then we'll take the other handle, or the other part of the handle, and we'll insert it in the knockout in the short piece of the handle. See, that's all lined up. We'll take two more of our bolts. So we have now the electrical plug in there, and as you can see, that it'll just require us to put the plug in, and we'll be fine. And then we'll attach the LED strip to the two terminals there. So there we go. And then finally, we put the handle in there so it's flush with the roof. And we put that in so the protrusion is actually facing up. And we take our last thread, a threaded bolt. You're free to adjust the size of the hole to whatever you want in order for you to allow in as much air, or allow as much hot air as you like to escape the chamber. So having done that, then the last step will be to take your LED strip, and as I say, this is what it's going to be looking like. This is just the top part. And then first of all, attach the leads to the plug, then move it along, and that's a gradual incline on the channel there. So as you take remove backing tape and place it in inside the chamber, it should stick, and that'll be fine, right? That's how it all works. So let's now that I've shown you how it works on this little piece of the chamber, we'll do the real thing. Just to demonstrate how this works out, we're going to put together this one with steel bolts, or steel bolts, and so you can basically see how that form of the construction will go. So here's our full-size chamber, and just to point out, there's two files for the electrical connection component there. There's one with an S on it that stands for small, and there's another one that says L for large, and there may be other sizes out there, and if there are, let me know in the comments, and we can easily craft up something that'll accommodate something that's not either of these two sizes. So we're going to use this one that we've got here. It's the large one. And as I suggested when we were looking at the basic assembly process, we're going to start this time by attaching the electrical connection first before we put our mount in. Now, there are two small Phillips or flathead screws in there, and it is marked positive and negative, and the custom is that negative is black and positive is red, so we'll remember that when we're hooking this up. And from a recent video, we have our jeweler's screwdriver with a Phillips head inserted. So we just back off on these two nuts or bolts. We put the negative in the negative. Tighten it up. And we put the positive in the positive. Tighten it up. There, that's good to go. Attached to our strip. So you're going to have difficulty seeing this, and I'll probably speed through it because there's not much point showing you what you can't see anyway, but we're going to be duplicating the actions that we did with this cut-off version for you to see what's going. As I say, we're going to start with putting in the large handle. Now we attach the other handle by first inserting it in the top. We put the bolts in the holes. There we are there. Now we simply put the spinner on the underside with the bolt or the protrusion facing up. We put the spinner handle in, and we take a final bolt, put that in. And so there we go, put together as this one was, and showing the interior now with our strip all wired up and ready to go. And now we just have to unravel and stick the strip. And as you can see, we can turn our ventilation top to where we want for keeping it as cool or as warm as we like. So I'll be speeding up as we apply the tape. I should point out that, of course, where we want to start is on this corner here by the plug, because that's where the wire stretches to. And so as soon as we get that connected, then we'll speed up. Oh, guess what? That's what the problem is. The 3M tape is helpfully coming away with the backing sheet rather than staying on the tape. So let's just correct that and start again. Wasn't sticking because there's nothing to stick to. There we go. Now there's sticky there. I'm forecasting much more success. Although because of this chamber size, it's kind of difficult to get in there. And there we go. We have a little bit extra. And just using our handy dandy Printable Science utility knife, we can cut this at one of the spots. Well, we should be able to. Remove the last bit of tape there. And fasten it down. And your uncle is Bob. So as you can see, you can just go over that looking for sections that didn't stick properly, and you should be all ready to go. Does it work? Well, let's find out. So we've got a power bar here, or at least an extension cord. We just take our AC power supply or brick, and plug it in. And the moment of truth, we've got a green light on our power bar. Yippee! Does it work? And as you can see, voila, we now have our ultraviolet curing chamber for our resin printer. So there you have it. Thanks for watching, and if you want to stay in touch with Printable Science, you know what you have to do. I also invite you to visit our website at printablescience.com, where all the science that fits we print.